Greetings, calculus people. Today we're answering a question that I know has just been burning in your hearts and minds. How do you take the derivative of an inverse trig function? Okay, are you ready? Let's do this. I'm going to take you through sine inverse, cosine inverse, and tangent inverse to find a general formula for the derivatives of those functions. After that, I'm just going to hand you the formulas for the rest of them, but it's important to go ahead and derive the first few so you can really see where those formulas have come from. Y equals sine inverse of x. We're going to find the derivative of that. Now let's back up a step. Normally you see sine x equals y. Well, the inverse of that just switches the x and the y. So sine y equals x. That's the inverse. That's the equation we're going to work with. And we're going to utilize our right triangle trigonometry with an angle of y. If you recall, the sine of an angle is opposite over hypotenuse. Well, we know that the sine of y is x, or x over 1, which means that the opposite side is x, and the hypotenuse is 1. Well, what's the adjacent side? Let's use Pythagorean theorem to solve for that adjacent side. X squared plus a squared equals 1 squared. So a squared equals 1 minus x squared. So the adjacent side is the square root of 1 minus x squared. Going back to our problem on the left, we're going to take the derivative of sine y equals x using implicit differentiation. Starting on the left, sine is the outside function, y is the inside function, because we're differentiating in terms of x. So the derivative of sine, cosine, keep the inside the same, and the derivative of y is dy dx. And on the right side, the derivative of x is just 1. Now we can isolate dy dx by dividing both sides by cosine y. We're getting closer, but what is cosine y? Let's look back at our triangle. The cosine of an angle is adjacent over hypotenuse. So for our angle y, that's square root of 1 minus x squared over 1. So therefore, the derivative of sine inverse of x is 1 over the square root of 1 minus x squared. We're going to use the same process for cosine inverse. Again, backing up a step, what you normally see is something like cosine x equals y, and we're going to take the inverse of that and say cosine y equals x. Again, let's pop into our right triangle trigonometry, and cosine is adjacent over hypotenuse. So if the cosine of y is x, or x over 1, we know that this time the adjacent side is x, and the hypotenuse is again 1. So using Pythagorean theorem, we can find what the opposite side is. In this case, the square root of 1 minus x squared. So then we'll go back to our original problem and take the derivative of cosine y equals x. Derivative of cosine is negative sine, so we get negative sine y dy dx equals 1. Divide both sides by negative sine y. Well, what's the sine of y? Sine is opposite over hypotenuse, so the sine of y is the square root of 1 minus x squared over 1. So if we pop that into the bottom of a fraction, there we have our derivative. Let me clean that up for you. Derivative of cosine inverse is negative 1 over square root of 1 minus x squared. Last one we're going to derive from the get-go is tan inverse of x. Same process, but maybe slightly more complicated. If you know that the tangent of x is y, then the inverse of that is tangent y equals x. Going to our right triangle, tangent of an angle is opposite over adjacent. So if tangent y equals x over 1, then the opposite side is x, the adjacent side is 1, and this time we're missing the hypotenuse. Still Pythagorean theorem, x squared plus 1 squared equals h squared. So the hypotenuse is the square root of 1 plus x squared. Back to our problem on the left, taking the derivative of both sides. Do you remember the derivative of tangent is secant squared? So we get secant squared y, dy dx equals 1. Divide both sides by secant squared, and we've isolated dy dx. Now secant, that's 1 over cosine. So the secant of y is going to be hypotenuse over adjacent. So hypotenuse is square root 1 plus x squared. Adjacent is 1. So 1 over secant squared y is 1 over 1 plus x squared. So those are the 3 big ones. Here's the rest of them. Either memorize them or learn to derive them. But a note on these, this says arcsine or sine inverse of u. Where did all these u's come from? U is a function. Could be just x, but if it's a function, then you need to use the chain rule. So u prime is its derivative. So these formulas are just showing you the chain rule built in. So go ahead and practice. We'll start by taking the derivative of sine inverse of 5x. So here's the formula we're working with. And the key is figuring out what is in that u position. So in that u position is 5x. So from there, we know that u prime is 5. That gives us the top. And then u squared is 25x squared. And then you just pop it all into the formula there. 5 over the square root of 1 minus 25x squared. Okay, let's do tangent again, starting with what is in the u position. Well, tangent inverse of the square root of 2x plus 1 means u is the square root of 2x plus 1. If you take the derivative of that to find u prime, you get 1 over the square root of 2x plus 1. And then u squared is just 2x plus 1. And pop all that into the formula. That looks terrible, but whatever. Like, it's the derivative, so we'll go with it. If you really want to clean it up, you can, but I don't want to. Okay, pause the video and try cosine inverse of x squared, please. Right, so in the u position is x squared. U prime is 2x. And u squared is x to the 4th. So our derivative is negative 2x over the square root of 1 minus x to the 4th. Okay, now we have a trig function within a trig function. Process is still exactly the same though. In the u position is cosine x. Derivative of that is negative sine x. U squared is cosine squared. And then pop those in to our tan inverse derivative formula. Sine inverse e to the x. You always got to do an e to the x problem, right? So in the u position is e to the x. U prime is e to the x. U squared is e to the 2x. And then there's your derivative, e to the x over the square root of 1 minus e to the 2x. Again, our life in calculus is not complete until we found the equation of a tangent line. So in order to find the equation of the tangent line, we need a point and a slope. They've already given us the point, so we need the slope, which is code for derivative. So we'll take the derivative of tan inverse, and just like we did previously, we find out what's in the u position. Is x over 2, or 1/2 x, u prime, just 1/2, u squared is x squared over 4. So all those get inserted into our formula, 1/2 over 1 plus x squared over 4. And then we just need to evaluate that at 2 pi over 4, or just plug in 2 for x. So we get a slope of 1/4, and we have a point, we have a slope that we can put into point slope form. I'd like to say hello and welcome to Jim. He's here for a short period of time, but I wanted to walk you through sort of a thought experiment on this one. So let's say this is the problem in front of you, and we're finding the derivative of tangent 4x minus y equals 4x. Just ignore the hint for a second. Normally you just be like, okay, derivative of tangent is secant squared, but there's an inside, so we're going to have to use the chain rule. So let's just dive into that. So secant squared, keep the inside the same, and then the derivative of the inside is 4 minus dy dx, and then the derivative of 4x is 4. Well, now we have to isolate dy dx, but before we do that, we have to distribute that secant squared 4x minus y through. Okay, now we gotta get just the dy dx's on one side and everything else on the other. And see, like, you can keep going, but is there a faster way we might be able to do this? Another way to think about this is looking at this problem here that we need to take the derivative of. I'm wondering if there's a way that I could isolate y a little faster. So watch this magic here. I'm going to take the tan inverse of both sides, and that'll give me the 4x minus y all by itself, because tan inverse and tan, they undo each other. So really what I have is 4x minus y equals tan inverse of 4x. Well, now I can isolate y. And then we just learned how to take the derivative of tan inverse. So the derivative of the whole thing is 4 minus, now don't forget here, the u position is 4x. So du is 4, and u squared is 4x squared. So that's just another way to think about that problem. And it's fun to have these little tricks in your mind to make your life a little bit easier as you go. Let g be the inverse function of f of x equals 2 cosine theta. For any x's between 0 and pi, find g prime of 1. So we're finding the slope of an inverse function at a point. That's what we did last lesson. So if you remember the process of that, first step is to remember that that 1 is the y value for our f of x. So we start there. 1 equals 2 cosine of x. Now we can solve for x. So 1/2 equals cosine x. At what angle is cosine 1/2? Cosine is 1/2 at pi over 3. So let's sum up the information we have so far. We have a function, and we're working with this point pi over 3, 1. We also have an inverse function, and its like partner point is 1 pi over 3. Right, so next step is to find the derivative of our original function. So that's going to be -2 sine x. And we want to find it at pi over 3. So we'll plug in pi over 3 to that. Sine of pi over 3 is √3 over 2 times -2 is -√3. So that means the derivative of my inverse function is just 1 over that. Last problem, and this is a calculator question, so grab your calculator. We're going to, of course, find the equation of the tangent line at pi over 4 -1 to the graph of this lovely fellow here. X squared plus x times the tangent inverse of y equals y minus 1. Okay, let's go. Hardest part is going to be finding the derivative. So always get to know your function before you begin. We've got just an x squared, and then x times tangent inverse of y. I'm going to have a dy dx pop in there. And because x and tangent inverse of y are being multiplied together, we're going to use the product rule. And then the right side's pretty straightforward. So here we go. Derivative of x squared is 2x. And then for the product rule, I'll give myself some brackets. Product rule is the derivative of the first times the second plus derivative of the second. So derivative of tan inverse y is 1 over 1 plus y squared. And because there's a y in there, we've got to tack on that dy dx. So that's the derivative of the second and then times the first. And I'm just going to pop him in front. Right? That equals. I'm laughing because like you do all this work and you're like, I'm just not done yet. On the right side, derivative of y is dy dx, and derivative of -1 is 0. Now it comes the algebra part, right? So this was the calculus. The rest is basically algebra. So I'll go through it quick, but pause the video if you need a little bit more time working through the algebra. So we need to get the dy dx's on one side. And then we need to factor out dy dx. And then divide. Wow, look at that. Easy, right? There's the derivative. Okay, so now we need to, I need to clean up my markings. Now we need to evaluate the derivative at our point, pi over 4 -1. If that's a little bit intimidating to you, I understand, but yay, it's a calculator question. So just take that, plug it all into your calculator, and you get the derivative is about 1.29326029. And we have a point, we have a slope, we have a tangent line. And always in the final stages, make sure you give me at least 3 decimal points. Give me at least 3 decimal points to any of your answers. So that finishes out Unit 3. Starting in Unit 4, we get to start applying this stuff. Hey, thank you for being here. See you soon.